So, hi, sveiki, hi. Today my topic is Exclude human, continuous deployment, and OpenShift, and I'm gonna talk about how we are doing automation in Metaside. Few words about me. I'm a JavaScript software engineer with a passion for DevOps, microservices, cloud platforms, Kubernetes, and all the great buzzwords that exists. In Metaside Business Solutions, it's a company based in Vilnius, Hurt. We are doing various development, engineering. We are building products, platforms, applications, APIs, microservices, and we are using various different technologies. We have different stacks, and so our goal is to build fast with fast phase and with quality actually. And the quality and fast phase is two contradicts. You can't build fast and with quality. So we're always looking for solutions, strategies, how to improve and how to automate things. So I'm gonna cover today what is continuous deployment, the definition of that, why to choose continuous deployment, instrumentation, what we choose. I'll talk about Git strategy, what we changed from what we had and what we have now, how we are organizing stateful sets, secrets, and also pipelines and stages I will describe. So, what is continuous deployment? The simple definition, this definition is by me, it's basically a strategy for software releases where each commit to the source control is treated as a potential release candidate and has all rights to appear in production in automated manner. A little bit of history. First time when the continuous deployment was mentioned in the internet actually was in 2002. It was Kent Beck who mentions continuous deployment at company Liveware, and 2 years later they succeeded. They implemented continuous deployment in their infrastructure. Now, it's 2019, 17 years passed, and Netflix, Facebook, Amazon, a lot of big IT companies, enterprises, best enterprises in the world is using continuous deployment at large scale, and they're providing automation tools to open source community also. And they're promoting this pattern, continuous deployment pattern, for all startups and other companies to start with that. So the theoretical model of CI/CD is very simple. Continuous integration. Everyone is doing continuous integration, yes? Of course. Continuous delivery. Then we have some quality gates like automated testing. We have let's say smoke tests in some gates. How much people doing continuous delivery? A lot. What about continuous deployment when you do deploy to production continuously? Okay, a lot of them. I don't know what you're doing guys here, but okay. So basically there is one step only. The extra mile is to click the button and approve deployment to production. But I call that extra mile, I call the not aiming to continuous deployment problem. So when you not aim to it, you basically getting some problems. So first of all, when project is growing, the life cycle is growing, and the stages are growing, functionality is growing, features are growing, you start to do manual testing eventually. There are also possibility to appear for central authority, which is central DevOps team, or the guy who knows how to do things and how to promote between the staging and production, or the guy who knows how to fix things in staging and production. And the time is the worst thing, because you are blocking the streamline, and once you block the streamline with that approval step, you have batches, you have features, changes that is batching together in one batch, and therefore your velocity decreases. So why continuous deployment in multi-site? We find out some of the problems that we had, which first one is unclear ownership of the project code bases, or it's not clear who's responsible in the process of continuous deployment in each stage, let's say. Humans are bad at repetitive tasks. We can't trust humans anymore to test test environment or to test staging environment. What if the API is not regressing? Teams have different CI/CD practices, and it's hard to unify them. It's hard to migrate between teams because the release process is different between the teams. Also, I mentioned the central authority, and we are not productive as we could be, and our velocity is decreasing, basically. So, the technical challenges that we had. The first one was multiple languages, frameworks. As I said, it's hard to unify builds and deployments. Lack of instrumentations. Traditional hypervisors doesn't offer the dynamic environment, so you're relying on virtual machines, and they are static, they cannot scale, and we need something else. Non-functional tests is not possible also. If we want to test, for example, fail nodes or fail clusters or fail containers, we want infrastructure to be self-healing. Also, rollbacks, it's hard to do rollbacks. For example, if you want to do continuous deployment, you have to engineer rollbacks that could be one click away. So you deploy something bad into production, you can easily roll back the previous version. And I mean roll back not only application, but the stateful sets also. And we cannot achieve zero downtime deployment. We couldn't achieve zero downtime deployment, and that was a big problem because if you want to deploy each day or 5 times a day, you have to achieve that. So the instrumentation was the key factor of the continuous deployment. First of all, first change was to change something in our infrastructure, which was container engine, which is right there. We implemented container engine, which was an orchestrator for container or management, and the stack after that looks like this. So first of all, the Git as a source control and the only source of truth. The Ansible for infrastructure provisionings and then cluster provisionings and even application provisionings. We basically write playbooks that later can be run in some of the clusters or projects. Kubernetes and OpenShift, which is basically the same. It's a container engine that is an abstraction of in your software. Also Jenkins. Jenkins with all the tools, some chaos tools, Sneak for package scanning, Gmeter for performance load testing, HashiCorp Vault for security, and OpenABS for stateful sets deployment. So yeah, it's opinionated instrumentation, but others can choose different products. There are always alternatives. Okay, so why we choose OpenShift over Kubernetes? The first question I think you have. So first of all, OpenShift builds security around containers, and we don't want to invest time in building security around containers. We want to write software. We like routers concept in the OpenShift. This is a bit different than ingress in Kubernetes. Also, we love image streams that can enchant your deployment configurations. And we have multiple clients, multiple projects, and we like the separation between those projects and clients. The question why we build around Jenkins. There is a lot of tools like Travis, CI, Bitbucket, Bamboo, and any other tool. So in our company, everyone knows already Jenkins, and we don't need to invest time in learning. Jenkins is very nicely integrated in OpenShift, which Red Hat is basically supporting the Jenkins image. Also unlimited flexibility with plugins. You can integrate with any system you want. And yeah, so basically we're using shared libraries. We write shared pipelines and share them across the teams. But you have to be careful because in the past we tend to overuse Jenkins. We build it as a master, and we run lots of heavy tasks, computing tasks, like Docker socket, and we did orchestration, and Jenkins was really a bottleneck for us. We did not try to make pipelines fast. We didn't use parallel stages. We did not prepare the agents for the tasks. We tend to put all the secrets, passwords, certificates into the Jenkins itself, and that was very unsecure. And I guess everyone tried that. And also, we didn't allow webhooks from the internet because Jenkins is not secure. You can't expose it to internet. But yeah, we managed to do that with webhook payload proxies, which works great. So, the Git strategy that fits continuous deployment. We borrowed one thing from the GitOps. You know what is GitOps? It's a new buzzword in the world. Everyone is now want to be a GitOp, but we borrowed only one thing, I guess. Everything as a code. Yeah, that's a great thing. And by everything, I mean infrastructure, configuration, playbooks in the code, builds, deployments in the code, CI/CD pipelines in the code. But the secrets is not, and I will tell you why later. All kinds of tests, of course, in code, schema migrations, automatic in code, everything else that you can imagine. So basically, Git is a source of truth. We also changed the Git strategy. Previously, we used the environment branches. I know it's very hard and complex. I don't know how to explain how it works actually, because it's complex. But you have probably 5, 6, 8 pipelines, various pipelines, and when it comes to release, it's like 5 days work for 2 or 3 people. So we introduced the Xflow. Who's using Xflow? No, should no one use Xflow because it's made up word, and the X stands for any Git provider. Basically, it's the same as GitHub workflow. But we say it's Xflow. The rules are simple. The one thing that stands out from the GitHub workflow is that we create dynamic preview environment when the pull request is made. And we also have branch matching convention over configuration approach, where, for example, you have 2 or 3 different branches on the same feature, and you want Jenkins to deploy your feature in that preview environment the same. Yeah, and Git tags, of course. We are tagging dynamic tag, which is latest, and exact tag of our releases. Okay, a little bit about Stateful Sets database. We use OpenABS high availability storage driver, which allows us to do synchronization between data sets, and therefore it allows us to do blue-green deployments of stateful sets. And in this case, we can do create dynamic environments and deploy databases with the applications itself. Also, we can do rollbacks, which is 2 features that we need from that. When developing, we focus on few things, which is automatic up and down data migrations, data schema migrations. You have to support that. We prepare C data because we always need C data in order to run integration tests. And microservices have, when we build microservices, we have a pattern, 1 database per microservice. Of course, this pattern is much more complex and not today's topic, but yeah. And unit testing data entities models. Okay, so how we are organizing secrets? Secrets, yeah. I think we all tried to add secrets in container by mounting them, adding in environment variables, passwords, connection strings. No one? Okay. I tried. We tried actually, and we felt bad because it's not secure. Anyone can access the container and see what is the connection string to database. So we decided to choose one of the vault. We actually explored a lot of vaults, and there's a lot of in the market, but we come up with two: Ansible and HashiCorp. So there are two questions. If you ask the answer to those two questions true, then you can choose Ansible Vault, and if not, you should go with HashiCorp Vault. And the reasons why: HashiCorp, basically Ansible Vault. When you're using Ansible Vault, you have to trust the person who configures the encryption. With the HashiCorp Vault, the encryption is out of the box, and they also have this great thing as Shamir shards algorithm for master key. And yeah, so you can basically shred your master key, which is used for sealing or unsealing the vault, into the pieces, and those owners who has those sharded pieces can unlock or lock the vault. So it's kind of, I think, one of the most secure solution nowadays. HashiCorp Vault usages. So we have two scenarios. First one is we build sidecar containers around our microservice container, and that container is responsible for issuing the tokens, and it's basically allowing application microservice to access the secrets, and also doing the leases, automatical updates of the token. Yes. Jenkins also authenticates through the vault with app role mechanism, and previously we didn't do that. We just put the secrets into the Jenkins. Now we are integrating with Vault, and before we start the pipeline jobs, we ask the Vault for the secrets. And this is how it looks like, the second scenario. Jenkins authorizes via Kubernetes, through Kubernetes, and gets the GVT token. Then it provides that GVT token, Jenkins provides GVT token and app role ID to the Vault. And Vault then checks the GVT token if it's valid, and if it's valid, it returns the token, which has limited time of expiration. And until that token is valid, Jenkins can access secrets in memory and use those secrets in memory while it runs pipelines. So basically, we are not storing any secrets in the Jenkins. And also, we are doing some perimeter security. I mentioned earlier that we do use the webhook proxy payload service, and it can be a lot of services. The most popular one is sme.io. So you build your client into your cluster or project, and that client is can access the server that can get the notifications from the GitHub, but the Jenkins itself cannot be called from the internet. Okay, pipelines and stages. So we have basically three pipelines. The first one I mentioned, the pull request pipeline, which is very simple. The Jenkins just clones the code, setups it, configures it. Then the second stage hits, and it's a parallel one. We do the build, we do linting, unit testing, package scanning, whatever we want. Then the Jenkins creates preview environment. Basically, it calls the Ansible API, which is Ansible Tower, basically. And that Ansible API, which is running somewhere in the cluster securely, can create the environment in the OpenShift cluster that you're running your jobs. And then it starts the integration tests. If you have some performance tests, we basically try to keep it simple, very fast. And then if everything is okay, Jenkins reports to the pull request that the test passes. The main pipeline is almost the same, but we have 2, 3, or maybe 4 environments, which is called dev, test, staging, UAT, and production. And we are doing the same, but we are not creating the preview environment. We are just building, deploying then to dev, deploying to test. Dev can be unstable. deploying to test, and once we deploy to test, we run integration tests and any other tests that we have. We run performance tests. We start running chaos tests, but very basically. Basically, you check the how application responds when the containers are down, services are down, if it is able to self-heal. And if everything is okay, we deploy to production, run smoke tests on production, basic functionalities. It can be integration tests also, and we report. And then we have scheduled production pipeline, which is very, very simple. It's run it has a schedule when to run each day, at least one time in a day. And yeah, we run smoke tests on it. We are still engineering and planning to run controlled continuous chaos tests, as the chaos tests are very dangerous. You have to control the impact, the blast effect of what happens if the services are down or clusters are down, so you have to be very careful. So we run in the main pipeline under the test clusters or test projects, and if we know that we can control it, we will transform them into the scheduled production pipeline. So there are a few deployment patterns. First three is very, very simple. You change one service basically at a time. You change only front end, you change service, or you change the database schema. There are also fourth and five, which is a composite deployments, where you change service or database, basically backend, or you change the interfaces, services, and database, which is a full stack change, which is fifth. And the sixth one is various other changes like initial application creation, provisioning in the cluster, and then content management changes if we have some. It's a bit difficult. It's basically for the APIs and the single page applications. It's more suited. And the feedback loops. We have how it looks like. Basically, each stage, each quality gate runs their job, and then it returns a feedback by default. And if something fails, for example in dev environment, I will show you. Like here, it responds and rollbacks to previous version. But if the preview environment fails, it responds and destroys the preview environment because it was not good. The feature was not good. And if everything is okay, this feedback line comes and we report at the end. Yeah. So that's it about my slides. You can find me at LinkedIn, at Valdas or at GitHub. I guess I have some examples in my repositories. You can check. So I will point now a person who will ask me a question. No, I'm joking. Just ask a question.